All right, so hey everyone, welcome to the another video. And in this video, we are going to discuss about a very interesting thing that is context anxiety of coding agents. And this comes under AI engineering and harness engineering. So if you are a developer and if you use coding agents in your day-to-day task, then I think you should understand about the context anxiety problems of LLMs and coding agents. And there might be chances that you are just wasting expensive reasoning model API calls because of this problem. And also, in the last, we also going to discuss about some ways and some common methodologies by which you can solve this problem up to a certain level. Okay, now to understand this problem, first let's just take an example, that is your school project. Suppose you have to build a school project and you just have 100 bucks as your total amount. Now within this amount you have to buy materials and then you have to make this project. By keeping this idea in your mind that you have to think about efficiency, you have to think about the correctness of your project within the certain deadline, right? Now, let's suppose, due to your poor management and due to your mismanagement, you have just wasted 60% of your amount and you have just completed 40% of your project. Now, at that point of time, you would realize that, hey, within the remaining amount, I won't be able to complete my project with correctness, efficiency, and by using a better material, right? So, now at that point of time, what you will do? You will start doing cheating. What kind of cheating it is? It is like you would have a tendency to just complete this project as much fast as you can because you have to achieve the deadline. But at that point of time, you won't think about material, a good material, and the correctness of your project. Like at that point of time, you would buy some cheap materials, and all of your focus would be I have to complete this project as much fast as I can without thinking about the efficiency, right? And this is the same problem that LLM faces. This kind of same cheating LLM does when they have context anxiety problem, right? And this is we called context anxiety of LLM agents, right? Now, to understand this in terms of AI engineering, let's just take an example. Okay, suppose I have a coding agent, okay, and I have gave it certain sets of instructions that it first you have to write the authentication code, and after that you have to verify it by some functional test cases or unit test cases. And once you are done with both these steps, then last just make a summary.md file which contains what we have implemented and done so far. So now let's deep dive its process. First, LLM would start doing coding part, and once it's done with the coding part, it start doing testing, right? Now, once it is working on the testing, it realizes that hey, there is some mismatch happens due to environmental variables or dependencies. How? Because in initial set of instructions I didn't give to LLM that you have to follow this tech stack, this version, and all these dependencies, right? So when LLM is now doing functional testing or unit testing, LLM would realize that, hey, whatever I've implemented so far, it is not matching with the dependencies of the current environment, or I can say current versions of the tech stack that I'm using, right? Now, at that point of time, what coding agent will do? It will start running some pip commands or some shell commands in their terminal, right? And believe me, whenever LLM runs some shell commands or some upgrade version degrade commands or any sort of shell commands, LLM waste a lot of AI tokens in that. And this is the problem where you have wasted lots of tokens of your context window. Now, still, task is not completed. LLM just implemented the code. It is not yet decided whether the code is correct or not, how much bug it currently has, right? So, LLM now will think, hey, my current task is not completed and my context deadline is also approaching. Now, at that point of time, LLM will think within the remaining current context deadline, I won't be able to complete this task in a very efficient manner, in a very correct manner. So now LLM will generate a tendency to just complete this task faster as it can, but not in a good way. Means LLM will start doing that task as much as faster it can, but not in a correct way. All focus of it would be I have to complete this task as much as fast I can. Right. Now, let's just talk about how exactly we can solve this problem. But before talking about the solution, suppose you have faced this entire steps, right? Now, what would you think? You will think, hey, I have used a worst or cheap model of LLM, and that is why my code is not completed and it was not correct. What if I tried to switch to an expensive model, expensive reasoning model, and then I can think whether it is giving me a better or desired response or not, right? And I would say that is not the correct step at that point of time, because switching to an expensive model is the last step of harness engineering, and most of the developers in today just do this as the first step, and that is the biggest problem, right? Now, if I want to solve this problem, okay, then what I'll do, I will provide better harness to my model. Now, what is the meaning of better harness to my model? Let's discuss it with some fundamental principles of harness engineering. And that is, whenever I'm providing sets of instruction to my LLM, it should be clear. Like all agents.md file, all instructions, version dependencies, everything should be present. And within that, I should provide enough context to my agent. Like it could be tools, resources, and MD files, progress files, task files, and project structure, repository context, and everything. Right. And in the beginning of the task, I should provide LLM that this is my current tech stacks and this is the current version I am running right now. All of my unit test cases and functional test cases are based upon that. So now LLM won't waste a lot of tokens just to implement the code which it was not supposed to implement, right? After that, we should have a proper verification feedback. Like we should have certain test cases, functional test cases, unit test cases that can correct the model, whether it's functioning, it's working correct or not, or whether model is going into wrong direction or not. And last but not the least is having a proper state management file. What is the meaning of this? It says that whatever we have implemented so far, we should have a progress.md file which states that, hey, while implementing this sort of feature, I have implemented on my coding agent, have implemented this much far. So assume if your context window is exceeded and you are now switching to new context window, then LLM don't have to read everything, the entire code, and from the start, right? It can just read your progress.md file. Okay, so yeah, these are the set of steps that you can use in your day-to-day life or in your day-to-day coding activity, so that you can save a lot of tokens. And instead of switching to an expensive or reasoning model, you can use your cheaper model to work it correctly, right? Although in the next video, I also cover a practical, like how by using the fundamental principles of harness engineering, we can, make our agent or cheaper agent or a less reasoning model working better, right? So yeah, that's pretty much I wanted to talk about in this video, and I hope you have understood the context anxiety problem of LLM coding agents. Yeah, that's all. Thanks for watching.